Okay, so how'd you feel about it? It's yeah, it's not that bad. Sometimes there's a few steps, okay, um, but it's not that bad. Okay, so the first few problems are pretty straightforward. It's when you get to the word problems that they get harder, but let's go ahead and go through these anyway. Okay, use the arc length formula to find the missing quantity. Okay, what do we always have to remember about this formula? Has to be in radians. Yes, the angle is in radians. And when you're solving for the angle and you get your answer, it's already in radians because this formula is set up using the radians. Okay. All right. So we've already got S and 3. So this one's pretty straightforward. 3 equals 5 theta. So theta equals 3 over 5. Boom. There's your answer. It's already in radians. You could put it, say, 0.6 if you want to, but it's not necessary. Okay. Okay. Let's round your answer to 3 decimal points. You can leave it like that if you want to do. If you put it in decimal form, you've got to put it the 2 zeros afterwards because we want it in 3 decimal places. Is what they said. Okay. Okay. The next one we're finding R. So again, S equals R theta. Okay. There's no degree mark here. So that implies that this is already in radians. Otherwise, there'd be a degree mark there. Okay. So we're looking at multiplying by 2. So we get R equals 12. So we're looking at 12. What's the unit? Feet. 12 feet. And again, that really should be 12.000 feet. That's just kind of annoying, isn't it? Okay. Are we good with those? Yes, Kevin.
Is there any time that you would convert that back into like convert it to degree at all?
Yeah, I mean, yes, and I think in one of our word problems we did that, if I remember correctly, because radian, the 1/2 radian doesn't make a whole lot of sense to you as far as understanding the angle that you're referring to. So yeah, there would be times where we would do that. Okay, I think one of the word problems was asking for the angle, and we would want that in degrees. Okay. Okay, so here we're looking for S. Again, S equals R theta. So we've got S equals 3. Now here we have theta is in degrees. So we've got to go ahead and convert that to radians. 120 times pi over 180. Okay. This pi over 180, that needs to be in parentheses. So please do it on your calculator while I'm here so that we can make sure that you've got that straightened out. We get pi divided by 180. And we get 2.094. Okay. In fact, I usually leave the entire number in there. So what I do a lot of times, I'll do 3 times. So my theta is going to come from this, right? So we're going to say 3 times 120 times pi over 180. So I just kind of leave the whole number right there. So on my calculator, I just did 120 times pi over 180, and we'll just do times 3. Now I'll go ahead and round it. Okay, we want to round at the end, not in the middle of the process. Okay, so this is going to give me 6.283. So S is approximately 6.283 inches. Yep.
What if you leave it in like I left it in 6 pi over
9? In this case, because they specifically asked for rounded to 3 decimal points, I'm going to say we need to go the extra step. And I'm glad that came up, actually. If you're told, okay, this is a general rule, and this carries on into calculus also. if you are told to round it to a certain number of decimal places, then that means go ahead and do the division necessary. Like here, 3 divided by 5, do that division. If you're asked for an exact value, then we're going to leave it like this. Or what was it, 3 pi? 6 pi over 9. Okay, so then you would leave it like that. Actually, that should be reduced 2 pi over 3. Okay, so then you would leave it like that instead. I don't feel like that's correct, actually. That doesn't sound correct. 6 pi over what? Yeah, 6 pi over 3. That makes more sense. Because 2 pi is 6.283. Okay, so if they're asking for an exact value, you should leave it like that. If you're told to round it to a certain number of decimal points, then that means they want this multiplied out. Okay, I'm not going to be that picky on the quiz, okay, but this is just something we need to get used to looking at. Okay, here we're looking for r again. So s is equal to r theta. So we're going to do 2 meters. The theta is in radians because there's no degree mark there. So I'm going to multiply by 3 on both sides. So r equals 6. So we're looking at 6 meters. Okay. Okay, now we're looking at area. Remember, area equals 1/2, what was it? R squared times theta. Okay, and again, the theta is in radians. Okay, so it says find the length and the area. Okay, so we're using both formulas now. So let's go ahead and find our S. So S equals 2 times theta. This is in radians, so that's 2 pi over 3. So we get 4 pi over 3. It says to round my answer to 3 decimal places. So I'm going to do 4 pi. Oops. Excuse me. Let's try that again. So that is 4.18879. So I'll round it to 4.189. S is approximately 4.189 feet. Good with that one? Okay, so let's find the area. So here we have 1/2. The radius is 2, so 2 squared, times the angle, 2 pi over 3. So this one just coincidentally, let's say that's 4 times 1/2, so that's 2. This one just happens to come out to the exact same value. Okay, 4 pi over 3, which is approximately 4.189. Only our unit this time is square feet. Okay. Okay, number 6. See, these are not too bad, right? Caitlin's bored out of her mind. Okay, S equals R theta. So we're looking at S equals R is 3, theta is pi over 6. So we're looking at pi over 2. So we have 1.571. S is approximately 1.571 meters. Okay. This problem, by the way, the way they marked it is very confusing or very deceiving because the pi over 6 over here almost looks like it's referring to this angle. You have to know something about your circle and your radians to know that that can't be the case, because a full circle is 2 pi, or 12 pi over 6. So there's no way. And then think about it this way, pi over 6 is actually 30 degrees. Well, there's no way that this is representing 30 degrees. So clearly that pi over 6 is referring to the inside angle here. They just couldn't squeeze it in there, so they wrote it outside. But I think that caused some confusion for some people. Some people did more work than they had to by figuring out, oh, well, that's 11 pi over 6. Yep. Or maybe you didn't. But I would have done that because of where it was marked. Okay, so we're looking at area equals 1/2 r squared, so 3 squared, times the radians of pi over 6. So we get 1/2 times 9 times pi over 6, which comes out to 9 pi over 12, or 3 pi over 4. Okay, 3 pi over 4, 2.356. Area is approximately 2.356 square meters. Okay? You good? You guys all got this? Okay, moving on to the word problems. These are more fun. A strawberry farmer needs to water a strawberry patch of 1,500 square yards that is in the shape of a sector of a circle with a radius of 40 yards. Okay, so here's my circle. Okay. Here's my sector. The area of that sector, okay, the area, because it says square yards, the area is 1,500 square yards. Has a radius of 40 yards. And we're trying to figure out the angle, okay? True application. I think I told you before, I actually remember doing something like this with my dad when I was in high school. We had just installed a new sprinkler system or a new irrigation system on the blueberry farm, and we did exactly this. We're figuring out what angle to put the heads so that it would reach the space that we had. So it was kind of fun. Actually, I think he was just being nice to me and wanted to involve me because he knew I like math. He's like, let's use your math, right? But we actually did this, okay? So the question is, what angle? So our area formula, 1/2 pi r squared theta. You can just leave it right there. Thank you. You feel better about it?
Yeah. No,
Okay.
I think I got it.
Okay. All right, we got 1,500 equals 1/2 pi. And what's r? 40. So 40 squared is 1,600. And then we've got theta. So 1/2 of 1,600 is 800? Probably. Okay, if you want to write it out, I'll sign it.
I need to look my other period.
Okay. Oh, write it out and I'll sign it.
Yeah.
Okay, so we've got theta equals 1,500 divided by 800 pi. Okay, so we're going to do that on our calculator. And again, I'm going to be careful with my parentheses. Divided by 800 pi. And I get 0.5968 blah, 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 blah. Okay? 0.5968. All right? This is a case where we want to convert this back to degrees. Okay? Leaving it as radians like that really doesn't make sense. Yeah.
Isn't there not a pi in the equation? Isn't it just 1/2 r squared theta?
Why did I put a pi there?
Yeah, because
Why did I put a pi there? Yeah. Did I do pi up here also?
no.
Ah, I don't know what I did. Why I did that. Thank you. Okay. Did I make any other mistake? Good. Okay, so let's do that again. 1,500. Yeah, why did I do that? Divided by 800. Okay, 1.875. All right. So we are going to convert that 1.875 to degrees because 1.875 radians doesn't quite make sense, right? So how do we convert that to degrees? Yeah, we're going to multiply it by 180 over pi. Okay, so I leave the number in my calculator and I'm just going to go times. So it's going to take that answer times 180 divided by pi, right? In this case, it's no big deal, but if it was that previous number, then I wouldn't be rounding. I'd just be using that whole number. Okay, so we get 107.42958. So what are we going to round that to? Must be 3 decimal places. Didn't it say 3 decimal places? Yes, 430, right. Oh, it doesn't say to round it. Okay. All right, so we're going to just say theta equals, I'll just do 107 degrees because it doesn't specify. Okay. We good with that? Okay, the last one was number 8. This was the hardest one. The minute hand of a clock is 6 inches long. Okay, 6 inches. How far does the tip of the minute hand move in 15 minutes? So it's going to move to here. Okay, so how far does it move? We're actually looking for that, which is what? That's S, right? S equals R theta. Okay, how about theta? So we've got 15 minutes. Well, how many degrees does it move in 15 minutes? 90 degrees. Yeah, it moves 90 degrees. So theta is 90 degrees, which is how many radians? Pi over 2 radians. Now, last night you labeled your unit circle, right? So that could have helped you. Of course, I don't have it on here. Okay. You labeled your unit circle last night, right? And you labeled this was 0. This was pi over 6, pi over 4, pi over 3. And here at 90 degrees, whoops, it was pi over 2. So as we learn our unit circle, we're not going to always have to sit there and do the calculation of 90 times pi over 180. Because by the end of next week, if you saw 90 degrees, you're going to be able to go, oh, that's pi over 2. Okay? So that's going to be really helpful to us. You like that left-hand snap? I was kind of impressed with the left-hand snap because I'm right-handed. I mean, we know we can do it right-handed, but left-handed, you know. Okay, you guys are really boring. Can you all, everybody, can you do this? Both hands? Come on, both hands. There you go. Some people can't snap. Isn't that funny? Like, we take it for granted. Look at Gavin. He's like, same time, man. It's like we do the salsa dancing, right? Okay. Yeah, some people can't snap. Isn't that funny? Anyway, I hope you're not one of those people. You're probably like hiding your hands right now. Like, okay. All right. Anyway, S equals R theta. So S equals 6 times pi over 2. So that is 3 pi. Now we're looking at a distance, so 3 pi really doesn't make too much sense to us. So we're going to figure out what that is. 3 times pi. That is 9.425. Is that correct? Approximately 9.425 inches. There you go. Right on? Okay. Okay, questions. This should be our new thing now, like when we get it right. Jessie just staring at me. She's like, she's got to stop soon. She's like, she can't continue like this. Just any questions? Okay, let's take a quick look at our unit circle. I really thought I had uploaded it. Oh, there it is. Okay, our unit circle. I'm going to erase some of this and I'm going to go through it with you. The videos that you're going to watch tomorrow, a couple of them are actually going to talk about how to actually fill in your unit circle. Okay, I have my own little strategy which I will share with you, and maybe they do the same thing in the video. But in the video, they're going to start talking about filling in the coordinates of the unit circle also. For now, I just asked you to fill in the radians. So starting with 0 degrees, that is 0 radians. Okay. 30 degrees, how many radians is that? Pi over 6. Okay. Now, I'm going to skip and I'm going to show you how I fill in the radians. Okay. Every 30 degrees is pi over 6, or another pi over 6. So we've got 30 degrees, so another 30 degrees brings us to 60 degrees. We're going to ignore the 45 degrees for now. So another 30 degrees brings us to 60. So this is actually 2 pi over 6. Another 30 degrees brings us to 3 pi over 6. We go another 30 degrees, that's 120 degrees. So now we're at 4 pi over 6. Another 30 degrees brings us to 150. So now we're at 5 pi over 6. And I'm going to just keep doing that. We get to 180, so that's 6 pi over 6. Another 30 degrees, it's 210, that's 7 pi over 6. Another 30 degrees brings us to 240. That's 8 pi over 6. Another 30 degrees brings us to 270. That's 9 pi over 6. Another 30 degrees brings us to 300. That's 10 pi over 6. Another 30 degrees brings us to 330. That's 11 pi over 6. And another 30 degrees brings us to 360, and that's 12 pi over 6. So I go around the circle. Every 30 degrees, I add another pi over 6. And then I just go back and I reduce. 2 pi over 6 is pi over 3. So 60 degrees is pi over 3. 3 pi over 6 is pi over 2. So 90 degrees is pi over 2. 4 pi over 6 is 2 pi over 3. So 120 degrees is 2 pi over 3. 6 pi over 6 is pi. So 180 degrees is pi. 8 pi over 6 is 4 pi over 3. So 240 degrees is 4 pi over 3. 9 pi over 6 is 3 pi over 2. So that's 270 degrees. 10 pi over 6 is 5 pi over 3. And then we have 11 pi over 6. And then 12 pi over 6 is 2 pi. Okay. Another pattern to observe is that every 60 degrees is pi over 3. So 60, another 60 degrees brings us where? 120. So now I've got 2 pi over 3s. Another 60 degrees brings us down here. So now I have 3 pi over 3, which is pi. Right? Another 60 degrees brings us down here. So that's 4 pi over 3. And then we have 5 pi over 3. And then 6 pi over 3. Okay, so that's another way that you can do it, just by 60 degrees. Okay, we're going to use the same strategy for our pi over 4s. 45 degrees, which is pi over 4. Every 45 degrees, we're going to do pi over 4. So this is going to be our 2 pi over 4, which we know reduces to pi over 2. And then we have 3 pi over 4 and 4 pi over 4 every 45 degrees. 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4. So you do not have to sit there and calculate every single one. In fact, you only need to calculate twice. You have to calculate for 30 degrees and you have to calculate for 40 degrees. After that, you just go around the circle, and every increment of that many degrees, you add another pi over whatever it is. Okay? So you need to absolutely, positively, by the time I come back on Wednesday, do I have you on Wednesday? Yes. You need to know this unit circle. Hint, 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 hint. When I come back on Wednesday, you need to know this much of the unit circle. Okay? Everybody got that? Questions? Concerns? If you can't snap your fingers, we can work on that. I'll give you some exercises. Snap your fingers and stand on one foot. Hop on one foot. Okay. Can you snap the opposite foot you're hopping? Okay. Are we good? Can you snap and hop and turn? No? Okay. All right, we're done.